All right, to add these two terms, what we're trying to do is see if we can make them like terms by simplifying those radicals. Here's what I mean by that. We're going to take the square root of 27, and I don't really care about that 3 right now. It's going to take the square root of 27. Let's split this up to see if we can get any matching pairs to pull out of that square root. So 27 I'm going to show is 9 times 3. 3 is prime, so I circle it. And 9 is 3 times 3, both of which are prime. So I'm going to rewrite this. Instead of showing it as the square root of 27, I'm going to show it as something different, but has the same value, 3 times 3 times 3. Okay, well, is there any matches there? Yeah, there's 2 3's right there, which is really 3 squared. And if we were to split that up, you'd have the square root of 3 squared times the square root of 3, and the square root of 3 squared. Since it's a perfect square, it's just going to come out as a 3, all right? Now that's important because it's a perfect square. The other factor, square root of 3, with that blue 3, is still, it doesn't have anything to pair with it. At this point, we want to remember that we had the black 3 up above, which we would then multiply by the red 3 to get 9. So we really have 9 times the square root of that blue 3. So that's our first term. The second term, again, I'm not really concerned about that 2 right there. So I'm just going to take the square root of 48 and split this up into its factors to see if I can find any matching pairs. 48 I would split up into, I'd probably say 12 and 4 maybe. Yeah, you know what, let's switch those. We'll call it 4 and 12. 4 is 2 and 2, which are both prime. 12 splits up into 2 and 6. 2 is prime. 6 splits up into 2 and 3, both of which are prime. So again, I'm going to show this as the square root of 4 2's multiplied together. 1, 2, 3, 4, and then the 3 right there. And here we do have matching sets of 2's. We got those 2's right there and those 2's. So it's really 2 squared times 2 squared. And yep, we'll take the square roots of both those. And then we have the square root of that red 3 remaining. Well, since these are perfect squares, that's 2 squared, which is going to pull out a 2. Same with this other 2. And then, of course, we still have that square root of 3, which we will keep. We can multiply these together, but now I would want to see that black 2 up above brought down, and that's multiplied by those other 2's. 2 times 2 is 4, times 2 is 8, so I end up with 8 times that square root of the red 3, and that 8 is positive, by the way, so we're going to pull it down as a positive 8. We know that from the plus sign up above. And at this point, it's important to realize that we have 2 square roots of 3. Okay, so that means we can combine these as like terms, square roots of 3. So we got 9 and 8, which we can then add, and 9 plus 8 is 17. This would be considered fully simplified.